Okay, thanks. Thanks for having me. I have a talk about hacks we are using during daily development. And first I would like to start with a random definition of life hack as I found it on the internet. It's supposed to be a technique adopted in order to manage daily activities in a more efficient way. Usually it's something like this, but I'm going to talk about like different types of life hacks, less practical. Almost all images in this presentation were stolen from the internet. They are not generated by AI. So what I'm going to talk about, first I will give like brief context about what we do because it's relevant for all the other topics. Then I have four hacks that I will go through and explain why do we need them, how do they work, and like what do they bring us. So first, briefly about what Apify is doing. We are a web scraping and automation platform for developers, and the product consists of a store of ready-made web scraping solutions, which is built on top of a platform which consists of several interconnected services, and that's built on top of our open source tooling. Yeah. I've been in Apify for 3 and a short portion of a year, so I saw how we did it before we introduced those life hacks I'm going to speak about, and how is it looking now after we started with them. And I'm going only to be focused on the platform. The other two parts are not relevant for this. So the platform is a complex product composed of several interconnected services, and it's really like separate products, not microservices, but like separate parts of the whole ecosystem. The code base is large, written mostly in Javascript and TypeScript. We are like in the process of typing it properly. It includes large monorepositories, a lot of legacy code, and the infrastructure is mostly on AWS. So the first life hack I'm going to introduce is that we are aiming to keep the local dev stack, so we don't have to develop against cloud services, even though the whole platform runs on managed services. Getting the stack is probably running the stack locally is pretty straightforward if you have like one database, but once you introduce the managed services, it gets more complex because they usually keep their own business and don't want to give up like free code for everybody to use. So why to have it? You can locally prototype your backend services that rely on the underlying AWS services. You can test locally. It's pretty obvious. You don't need the DevOps team to onboard new people because you don't need to spin new instances of the managed services. The testing, of course, is only to some extent because in production it runs on the managed services and they have their own ways of being. The cost is better because it runs on your laptop and you don't need to pay for the managed services. And we just got new t-shirts which say like it worked on my computer. And on top of that, if the whole internet is down, we can run the full platform on the computer, but there will be nothing to scrape. So we want to keep the dev stack as long as possible, because it scales the development well. But at one point, we almost needed to sunset it because of the computing capabilities of our machines. But then the M1 processors came and we could continue with it. But now we are in a state that it could run again on the slower computers because it got more efficient in the meantime, like the dev stack itself. The structure, it lives in a standalone repository because it contains underlying services for all the interconnected applications that I mentioned. And it basically copies a subset of AWS and adds few other services. As you would guess, it's mostly based on Docker Compose with few custom Docker files and some utility scripts. There is one thing that does not run in the containers, and that's all our Node apps. Those run directly on the host. The tooling around them is very good with all the Node version managers and local packages, so it keeps all the stuff isolated and doesn't bring any problems. So there is no need to include it in the dev stack. Now I would like to briefly show what's inside. It's not really important. It's just some containers, but there are like few specific ones which somehow show what you need to deal with if you run most unmanaged services. For example, DynamoDB, which is a key value database provided by Amazon. They have their own image that you can actually use and put it in your stack because there is no other way how to replicate it. For the registry, like Docker registry, here the situation is that AWS adopted the same standard as Docker Hub, so the official registry image from Docker Hub works the same way as the Elastic Container registry. Then the other way around, AWS created SQS, and everybody, no, not everybody, but a lot of other services started to provide the same API. So you can just use it as a drop-in replacement. Similar example would be S3, but currently we are using the fake S3 because of some problem with cores on pre-signed URLs. I'm not sure exactly why, but it's like this. Other example is that somebody created a fake service that emulates another popular service. Algolia is a search engine. Algolite is a clone of it that runs in a single process and has almost the same API. For this, we have a custom Docker image because it's just a library, node library, and it doesn't have Docker image, so we need to put it up ourselves. Then Redis, we have several Redis containers because we need to run it in the cluster mode. So one container is not enough. And then the last thing is one container that waits for everything else and runs some initialization scripts. One of the examples is that it sets Mongo as into the replica set mode. Okay, this is what it looks like if you start it. And if you see the Apify logo come up, it means you can start developing, that everything is running. Since we learned how to do colors and logs, we started using it basically everywhere. So this is one of the examples. Next thing we are using the containers were mostly about services that run on AWS, but we also need other services. One good example would be sending emails. I guess almost everybody uses some external service for that because of the availability and everything. And here it's pretty straightforward. Instead of being dependent on just Mailgun, we are depending on an interface. And in production and staging environments, we use Mailgun, but for the local development, we just trust that the Mailgun will work, and instead write the emails directly to disk so we can check if the HTML looks okay and check if the headers are fine. But so we are fake it on the code level, it's not part of the containers. Of course, this whole approach has some limits. One would be that not all services are one-to-one with their cloud version. For example, MongoDB has official image, but the image doesn't have the Atlas search capabilities. So for proper text indexing and search, you cannot use the local image. It only works in the cloud, so we are trying to not use those features if possible. And then there are some services that we share with the staging environment. Those are mostly like some analytics tracking and stuff like that. Maybe even like payment gateways because they have the sandbox accounts. And yeah, so that was the first part, and I'm going to the second life hack, which is seeding test users. On our platform, basically all the functionality is hidden behind the login. So in order to actually test something, you need to be a user who is already logged in, the account is created, and stuff like that. So we cannot just click through the application without the actual user. So before we started seeding test users, and by seeding, I mean like generating the user objects automatically. Before we had very few Cypress tests. We were limited by having fixed test users which were created on the staging environment and locally, which meant that the tests couldn't run in isolation. For example, you cannot test in parallel user who is on a free plan and user who is on a payment plan. You would have to test this sequentially. And it was like hard to maintain because the data accumulated, the test crashed with all kinds of problems. With the seeding, we have a growing number of tests. The parallelization is better, maintenance is easier, and the testers are happier. We needed all the tests need to start in some initial state of the application. For us, it's at least that the user is already signed up and can start interacting with the application. For the sign up part, there is like a different special test, but like all the relevant tests that test the behavior inside the application need to start somewhere. If we did it the same way as users, so like clicking sign up, filling in the sign up form, going through the whole registration, it would take a lot of time, and by a lot of time, it could take like up to an hour because we have a lot of fraudsters on our platform. So we have some protections there. So in order to subscribe, you need to have the account for at least like 1 hour because otherwise it's almost certainly like a fraud attempt. So if you were to do this the same way as the user, you would have to wait 60 minutes before every test. That's a long time, so no go. What you could do, or like how I did it like in different projects, you can take a database dump and like upload the dump to database before each test, and then like start with that. That has some like downsides, some problems as well. One of them is that the code changes fast. You would have to do like new dumps, I don't know, 2 times a day. Otherwise, you would be testing against outdated structure of the database, outdated data. Also, it doesn't work well for feature branches. For example, if you would start developing some feature, we would need to create a new dump that would be relevant just for the new feature. And and also, we don't have a single database. We have the S3 and DynamoDB, so we would need to have dumps for all of those, and those would have to be in sync. So also no go. So we have a shortcut that helps us to get to certain application state fast. This is how it looks like in Cypress. There is a task defined called backdrop-seed. It gets this very schematic structure, like a declaration of what the initial state looks like. You can see that there are like few users with like no other information, one organization, the organization is owned by one of the users, it is subscribed to some plan, and it already has some data filled in. Actors are like the basic entity in Apify. So once this task finishes, it resolves with IDs of everything that was created, and the application is in the state that was described with this schema. I have to give credit to our ex-colleague Strike. You can follow him on Twitter. He came up with the naming and with the basic principle of how we should do this. Yeah, what it does on the background, it just calls some endpoint which creates the users, organizations, creates the subscriptions, creates builds and runs the actors. And that happens using the same code that would be called in real life. So all the records are created, all the background tasks should be triggered, and all the other stuff. But it's not exactly the same code. There are some reasonable defaults at it. So for example, you saw that there's like no address filled in for every of the users, even if we need address for them to be subscribed to the plan. So the address is like fake generated. And there are some tweaks, for example, bypassing the 60 minutes check before creating the subscription. So we call this endpoint, and we have the application in a state where we can start actually testing the one specific feature that we are interested in. Apart from that, we have like few other seeding endpoints, which are mostly used to provide some data about like historical usage, because you cannot get them locally. Your application would have to be running for a few months to get data for all the charts, and there would be like drops over the weekends because you don't run it on weekends. Yeah, and those data are randomly generated because that's all that's needed for the charts. That brings us to the third hack, and that's interaction with your application, our application. Mostly for purposes of development and exploring what actually the legacy code does if you need to experiment with it. So I have like a motivation example where you enqueue a message to some messaging service, and because you are, say, writing a handler that's supposed to process it. I call this common ways because I've tried all those things, how to like play with the code. The first way we'll be doing is the same way as users. It means getting to the same page, clicking the same button, and that results in calling an API endpoint, probably. So we would call the endpoint directly, but that means you would still have like all the other side effects of calling the endpoint, not just enqueuing the message. You could create some ad hoc endpoints just for testing. That means you have to provide the payload basically in its full. If it's some huge JSON, you have to generate it first, write it manually, and then pass it to this endpoint. The same would go if you created like a ad hoc CLI command instead. And the other way you could do is like to write it directly to the underlying service. If it was built on the custom database, you would just insert the record to database. But again, you would need to create the exact shape manually. So neither of those is very flexible. So instead, you can use code to interact with your code base. Because Node has interactive mode, usually when I used it before, I just searched how to like exit it. It's .exit. I never used it for anything practical until now, because it turns out it's very easy to customize it. There's a module in Node Core, and those like lines are enough like to start your own CLI. What makes it your own is that you can pass anything to the context you are working with. So this container variable, then you have access to it in the CLI. Also, you can do all kinds of initialization and stuff like that. Yeah, you can to start it like with your environment. This is all that's needed. Usually, you pass the environment via environment variables. If you do it like this, and your say dependency container just takes the stuff from the environment, you would have the your own CLI. This is how it looks like. Just to show that it works, you have access to your code, and you have access to your environment. That's like all you need to interact properly. To show it in the same detail, you have access to your code and to your environment. But if you compare it to all the methods that I was showing before, this is completely generic. You don't have to generate the payloads. You can use your regular methods to generate the payloads, and you are not limited to using this just for the encoding the message. You can use it for all other services with zero other effort. Okay, just note that it's not supposed to replace testing. You can take it one step further, and you can have like a Jupyter notebook over your code base. You just need Jupyter and the kernel that's able to run JavaScript or TypeScript. Sadly, this is the tricky part. The one that we tried, TSLab, works, but it's not super great to have to. It doesn't work well with the imports and stuff like that. But it works, and you can have the notebook, which is even more convenient in the end than having just the CLI. Yeah, but in order for it to be really useful, we would need like a better kernel, and there might be some like on the way. And I didn't try all of those that were listed on the Jupyter kernel pages, kernels page. So the last live hack is debugger in production, which sounds stupid, but it sounds stupid only until you see a chart like this, where the CPU peaks. It happens only in production. You have no idea what's happening, and you are not able to replicate it. So it would be really handy to start the debugger in production. Node docs say that the process will start listening for debug messages if it receives the SIG user round signal. What's important is that it is still the same process. It doesn't like start a new process with the debugger on. It just turns on the debugger in the current process. In our case, it's really straightforward. So we just have the payload running in the workload running in Kubernetes, and there is just like one pod with one container with one process. So we just like send the signal, then you forward the port to your machine, and you can use like anything to any debugging standard debugging tool to work with it. Here's an example of how you can do it on just like the Chrome debugging tools. In the case of the CPU leak, we were able like to profile it, and then like I'm not sure if we actually find it using the profiler or with something else, but it worked. And I wouldn't know about this if we didn't have like regular short meetings on Friday called Tech Coffees, where we share stuff like this. If you find something that's interesting, just share it with your colleagues. Usually it's cancelled because they're not topics, but sometimes it is gems like this. Yep, so the summary of the live hacks is that we develop locally, we interact with the code, we have up-to-date test data, and if that doesn't help, we debug it on production. So thank you, and if you have any questions.
Guys, do you have any questions?
I have a question. Sorry, go ahead. I have a question for whatever
superpower?
I'm using it while developing and just like playing with the specific methods that I.
Also, like instead of just like fiddling with the UI to like because
Yeah,
so if you want to like quickly get into
Yeah. It's pretty fast and it has like a built-in help because we can like print any text in the beginning. So I usually just take that, copy it, and.
You mentioned former colleague of yours, but I didn't understand the name.
It was Pavel Doleček, and on Twitter it's Strike.
Strike?
Strike. Written as STRA.
I have a question about MongoDB. You said that you were doing it without Atlas. What was the most thing that you have lost? Like, what's the most important thing? You said indexing. So in search, you had issues.
Yeah, like we are in production with runs on Atlas.
Okay.
But locally we have just the Mongo image.
Okay.
And the features that it's missing is the like advanced, like it's called Atlas Search, I think.
Yeah.
And I think it runs some extra processes based I guess Elasticsearch or something.
Okay.
And that's not included in the image. So it's this, and then some, I think it's called MongoDB streams, which allow you to observe the changes.
Okay.
So those two features we cannot use. And actually the streams is something that we would use if there was the option.
Thank you.
Cool. One more security questions about the seeding endpoint, like how do you disable it in production?
In production, it's not there.
Yeah, it's not there. Oh, and second, if you enable the debug mode, can you also disable it with a signal, or you need to kill the process?
That I don't know. But if it peaks, it dies. So it disables itself.
Thanks.
If there are no more questions, thank you again very much.